Okay, so we're back talking about section 1.8 for college algebra, where we left off on the last video. We were talking about if you had an absolute value equal to another absolute value, and this was the U-try that you were working on. We had absolute value of quantity 3x plus 2 equals absolute value of x minus 5. So those two absolutes are set equal to each other. So there's two possibilities. Either we want to find what makes these numbers the same number by setting these two equations equal, and so that answer is negative 7 over 2. And then we want to know if there's a number that makes these two opposite in sign, like say this was negative 7 and a positive 7, their absolute values would still be the same. So we ask, by doing an equation, what makes this quantity, 3x plus 2, equal to the opposite sign of this quantity, a negative in front of the x minus 5. And so that solves to be positive 3/4. So there's two answers to this equation as well. All right, so the next thing we're going to move to would be let's address like the special cases. So we've talked about if you have an absolute value of say 3x plus 3 equals 2. So if you have an absolute value equal to a positive number, that's 3x plus 3, absolute value equals 2, that there's two answers to that. Whatever would make this positive 2 and whatever would make that quantity equal negative 2. Either positive 2 or negative 2, its absolute value is 2. So we work through this and get our two answers like we did earlier in the last video. Get negative 1/3. And let's see, what's this one? It's another fraction. It's negative 5/3. So there are two answers to that. But what if the original problem had started out with an absolute value equal to a negative number? So let's say that would have said negative 2 in the beginning as the original problem. In that case, no reason to even proceed or try to work it because there's no reasonable answer. There's nothing we can plug in for x times it by 3 and plus 3 so that its absolute value equals a negative number. So if it starts out with an absolute equal to a negative, that's just kind of a special case, maybe trick question. You might consider that. There's no answer to that. If you think about that, you can see that's an unworkable problem. There's no solution. So we'd say the empty set. Okay, so watch out for those. If we say the absolute value of what number equals negative 7, for example, trick question, there's nothing you can take its absolute value of, it comes out negative. So again, those are no solutions. But let's say the problem has some other stuff going on, like maybe 3x plus 3 an absolute value, and then a minus, let's say minus 7 equals a negative 5, for example. Now in this case, you've got some extra stuff outside your absolute value signs, and we need to get that isolated. We need to move this negative 7 across the line and or isolate our absolute value sign before we make a determination of if it's workable or not. So even though this says negative 5, it needs a little cleaning up first. We can clean up this equation. Again, throw the negative 7. It's not inside the absolute value sign, so throw it over to get the absolute value isolated first. So you see, now I see it is an okay problem. This is one like we worked earlier. We can work it. So don't let that stop you. First steps first is isolating the absolute value signs by taking anything that might be added or subtracted outside of it or even multiplied on the front of it. If there were some other operations outside the absolute, move those across the line by throwing terms across the line, or dividing if there's a multiplier. Isolate that first. Then if this number is a positive number, you'll be able then to work it. You'll get two answers. You'll set it equal to positive 2, equal to negative 2, and work it out. All right, so that's all the things I can think of with absolute value equal to a number. Now we're going to talk about absolute values and inequalities when you've got the greater than, less than symbols. So back to your book. If you're following along in your book, we're moving to the next example. On page 164, example 2. So we have absolute value of 2x plus 1 less than 7. So let's think about what this means. We're looking for a number we can plug in for x. You know, we're always looking for x, right? We're always trying to figure out what would solve this. What numbers we can plug in for x, times it by 2, add 1, and that absolute value, which is going to be a positive, will be less than 7. So all the things that would make it less than 7. Now, let's do a simple, let's go to a simple example before I get on to this one. Let me back up a little bit. What if it would have just said x? We can see that without all the other operations around it. A simplified problem, an absolute value of a number that's less than 7. What do those numbers look like? Well, think of some numbers that their absolute value is less than 7. You might think of 6, maybe the first thing that comes to your mind, or 5, or 5 and a half, 0. But then there would also be the negative numbers, like negative 1. If we plug negative 1 in for x, negative 1 becomes positive 1. That's still true. Negative 2, negative 3, 4, 5, 6, 7. What about even back to negative 7? When I hit negative 8, though, or anything past negative 7, say I hit negative 8, the absolute value of negative 8 is going to be positive 8. Is 8 less than 7? And no, we've gone too far. So it evidently stops. It turns around when we get to the negative 7. And then also when we get to the positive 7 side. So it's this closed-in interval. If we were doing find all the numbers whose absolute value is less than 7, it would be the normal things you'd think of, like 0, 1, 2, 3, and their fractions up to 7. All of those things apply. But then also the negative numbers back to negative 7. So it would be from negative 7 to positive 7. Or in other words, it would be x is less than 7 and x is greater than negative 7. So this leads me to the procedure. I like to think of it like this. The process is, you write it like it is, x is less than 7, so drop the absolute value signs, write it as it is, and then write it again with the inequality symbol flipped around and a negative. That's the other half of the story. So naturally, the thing's less than 7, but then also we need to stay ahead of negative 7, because if we hit negative 8, we've gone too far. Negative 8 would turn to positive 8, which is not less than 7. Alright, so if I were doing absolute value of x has to be less than 2, I would write that as x has to be less than 2, but x is also greater than negative 2. So from the interval from negative 2 to positive 2. So we're going to use that same process on this inequality. It's a little harder to see where you've got operations around your x, but it's the same procedure. You write it like it is, what makes that quantity less than 7, but then also what makes that quantity 2x plus 1 greater than negative 7. So you write it twice, one as it is, and the other one with the inequality flipped and a negative. And then we solve these. So I'll minus the 1, just like we do when we solve equations. Divide by 2. X is less than 3. So that's part of the answer. Then do it for the second case. Move the 1 across the line, or minus 1 from both sides. Makes that negative 8. Divide by 2. X is greater than negative 4. Alright, so what are those numbers? Numbers that are greater than negative 4 but less than 3. Let's talk about that on our number line, how that would look. Let's say negative 4 back of there somewhere, and then positive 3 over here. It has to be greater than negative 4, so this way, greater than negative 4, but also less than 3. So it's that closed interval, as less thans are always going to wind up being a closed interval between negative 4 to 3 on the number line. We could also write that in interval notation as negative 4 to 3, like so. Notice there's no line under our inequality, so when there's no line, we use parentheses. If there's a line under it, we use the brackets instead. Alright, so I'm going to give you a you try. You know I do that. And you're always invited to pause the video and practice this before we proceed. I think that is helpful. So your you try is absolute value of 4x minus 6 less than 10. But I'll keep working that. The procedure is you write it like it is, write it for the less than, and then you'll write it again with this turned around, greater than negative 10. and then solve through each inequality, just like you do with equations, except, and you learned this in a previous section, if we divide by a negative, we have to flip our inequality sign. That's still going on here. That's an always true rule. So I just haven't had any negative signs on my variables to give me that situation yet. But negative 10 and 6 is negative 4. There's negative over here, but I'm dividing by a positive 4. So that does not flip the inequality. So x is greater than negative 1. Now your final answer, usually they'll want that in interval notation. So I like to see it on the number line. Greater than negative 1 would be this way, and then less than 4 back this way, or a closed interval of negative 1 to 4. Negative 1 to 4 in interval notation. Okay, now let's do a greater than problem. Moving on to B part. Absolute value of 2x plus 1 greater than 7. So we want to write it like it is. 2x plus 1 greater than 7. Then write it again. 2x plus 1 less than negative 7. See how we change and change. Two changes on the second part. Then we solve these equations. 2x greater than 6. Divide by 2. X is greater than 3. That's one of our answers. The other one, we minus the 1 and get 2x is less than negative 8. Divide by 2. X is less than negative 4. So let's look at that on the number line. Now we've got a greater than, and it's going to look a little different. It's going to be an open interval or a split apart interval on this one. Greater than 3 goes this way. 3 and then greater than is going to go to the right. So it's going to look like that. And then the other one is less than negative 4. So from negative 4 back to the left of that somewhere, and then less than goes to the left. Notice our interval is split apart. So how are we going to write that? We're going to write this interval as negative infinity up to negative 4. And again, no line under these. So when there's no line, you use a parenthesis. And we put a union symbol. And then the next interval is 3 to positive infinity. And that would be how we'd have our final answer. Okay, so now I'm going to give you one to practice just like this one. You try. So again, pause the video and do so. Let's do greater than. So your U try is absolute value of 3x minus 4 greater than 8. So we write it in our two forms like it is, and then with the inequality sign flipped around and a negative. This solves to be a 4 greater than 4. So that's one of our answers. The other one, when I add the 4, it says 3x is less than negative 4. Divide both sides by 3, and x is less than negative 4/3. So these will always split apart. When you have the greater than inequalities, you wind up with a union symbol. So we have greater than 4, so 4 and then to the right. And then less than negative 4/3 to the left. So we're going to need a union symbol because it's split. This is our negative infinity up to negative 4/3 interval, union or plus 4 to positive infinity for your final answer. Now just like before, if you have any addition or subtraction symbols outside of the absolute value signs, you should isolate your absolute value signs before doing these as well. So that's what example 3 addresses, example 3 and 4. So let's see if we can do one more of these before the video times out. Example 3, notice has an extra minus 1 outside of these absolute value symbols. And what we learned earlier is you always want to isolate by throwing any outside side operations. Get those moved over either by doing the opposite sign, or if it's multiply, you'll divide that out. But we're just going to simply move the 1 across the line and isolate our absolute value sign, making that 5. And now we can write our two problems and proceed. So Just wanted to remind you that's an issue that you address with the inequalities as well as with the equations. You always isolate the absolute value signs, then do the original, and then plus its revised one when you flip the inequality and the sign.